Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 6, unit number 8. The title of unit number 8 is Functions and Graphs. In this video lecture, we will discuss the method used for finding the inverse of a function. In other words, you can say that in this video lecture, we will learn that how we can find the inverse of a function. Before to start the procedure for finding the inverse of a function, in previous video lectures we discussed in detail about the concept of the function. You all know that function is such type of a machine or a rule or a technique in which for each input mean the independent quantity, independent variable, there exists one and only one mean unique output, unique dependent variable under that mapping, under that rule. So this is the if I revise in short, function is such type of machine, or technique in which for each input the output must be unique. So in simple word, this is the definition of a function. Now from arrow diagrams we discussed different types of functions, that are a function which is onto 1 1 and n2, and a function which is onto as well as 1 1 is called bijective function. So remember, we already discussed that in previous video lectures. If a function is bijective, if a function is bijective, then its inverse will be a function, and the inverse function will also be bijective, and the inverse function will also be a bijective. Bijective mean 1 1 and onto. 1 1 function is also called injective function, and onto function is also called surjective function. For example, if we have a rule f from set A to set B such that when you give a value from this set A to this rule, to this technique, and you get, and this function operates on that value, and you get a unique value in this set. Let's say I am taking a value, let's say small x from this set. So when you plug that small x, which is the input from this set, so this rule, this technique, which is denoted by small f, operates on that x. This is not the multiplication of f and x. This means that this f is operating on x. This x is an index of argument of f, and from this f of x you get a value, let's say y, and that y must belong to set B, and that y is unique for this input x. So this mapping, this technique, this rule is called function, or in other words you can say mapping. Now in the definition of the function, for each input you must have a unique output. The outputs are called images. So whenever you have unique images for all the inputs, and inputs for which the function gives a defined value is called the domain. So in other words, we can say that when for each value of domain, if the images are unique, then such a relation is called a function. This is another definition you may write. Okay, so that relation is called a function, which we already discussed from the arrow diagram. And when all the range values, mean all the range and codomain values are equal, mean all the codomain is scored, mean range is equal to codomain, such functions are called onto function. That onto function must be a function, means satisfy this condition, as well as the codomain is equal to the range. This whole set B is called codomain, and the values that you get by putting the inputs from this domain in this function and get some values, let's say y1, y2, y3 of this set, and so that value is called range, and this whole should be is called codomain. So when codomain and range are equal, so then that function is called onto function. And whenever for each range value, mean for each image of the input, you have a unique pre-image. If the pre-images are also unique, then such type of functions are called one-one function. One-one function. This onto function is called surjective function, and this one-one function is called injective function. So if a function is onto as well as 1 1, so such type of function is called bijective. And remember, the inverse of a bijective function must be a function, and that inverse function is also bijective, mean that inverse function will be also 1 1 and onto. Now the question arises that how you can find out the inverse of a given function. So remember, if a function is given in the arrow diagram form, for example, if a function is given in the arrow diagram form like this, for example, function is given in this form, let's say this is x, and let's say this is y, these are the two sets, and you see 1 2 3, this is let's say 1 4 9, 1 is mapped with 1, 2 is with 4, and 3 with 9. So you see that the function f from x to y is bijective function, because this is 1 1 as well as onto. Now this is your domain, this is your domain, and this is your range. So if you are finding the inverse of this function, so the inverse of this function is, let's say, g, and that g will be denoted by f raised to the power minus 1. This f raised to the power minus 1 doesn't mean that this is equal to 1 divided by f. This is the notation for the inverse of the given function f. So this may be denoted with g. So this inverse, now this is a bijective, you see from the arrow diagram. So if you are finding the inverse of this function, and this arrow diagram of the bijective function is given, so you need to replace domain by range and range by domain. Just interchange range and domain. So the inverse function domain must be the range of the given original function, and its range will be the domain of the given function. So that will be the inverse, and that inverse in diagrammatic form will be like this: y come in place of the domain, and domain will be in place of range. and the mapping between them is f to the raised power minus 1, mean this is the inverse of the given function. So 1 4 9 1 2 3, so 1 is associated with 1, 4 with 2, and 3 with 9. So you see that this is also bijective. So this is the way to find out the inverse of a bijective function when that function is given in the arrow diagram form. This is so easy, just replace interchange range and domain. Now if a function is given in the algebraic form, then how you can find out the inverse of that function? Before to discuss that, remember we studied these 2 points in last video lecture, that linear functions they are bijective. All the linear functions are bijective. You know that f of x is equal to mx plus b, where m and b are constants and m not equal to 0. So this is linear function, so they are bijective, as well as the okay, so just remember this point, they are bijective linear function, and the domain of the linear functions are set of real numbers, and the domain of the quadratic functions are also set of real number. But remember, the linear functions are bijective. Okay, because the graphs of the linear functions are straight lines, so that's why they are bijective. Okay, now we are switching towards the method in which we will know about the procedure, that how we can find out the inverse of a function using algebraic method. So for that I am considering an example. Now we will use algebraic method when the function is given in algebraic form. So how you can find out the inverse? So I am taking an example for this procedure, and with the help of the example we will understand this method. Let we have function from R to R, mean domain is from the set of real numbers and range is also from the set of real numbers. Be a function defined by f of x is equal to 2x minus 1. You clearly see that the function is a linear function. So you all know that when a function is linear, so the domain of the linear function are set of real numbers, and its range is also set of real numbers. So that's why the mapping f is from R to R. This R is notation for the set of real numbers. Okay, we need to find f inverse of x, mean you need to find out the inverse of this function. This is the notation for the inverse. So in step number 1, how you can find, there are 5 steps. Step number 1, in step number 1 you already know that when we write f from x to y and we gave a value x from this set to this technique, this mapping like this, f of x. So when this f operate on this x, so you will get value, let's say y, and that must belong to this set, and if this y is unique for this arbitrary input, so this mapping is called a function. So we are usually denote f of x is equal to y. So in step number 1 you will replace this f of x by y. This is step number 1. As y is equal to f of x, so this implies that y will be equal to the value of f of x 2x minus 1. So this is your step number 1. You didn't need to write 1 2 3, but I am just writing it for your understanding. Now in step number 2, this is your step number 1. step number 2. In step number 2, you need to solve this equation per x. Mean you need to make x on one side and the rest of the values on the other side. So solve for x. You must need to solve it for x. So shift this one on this side, so that will become 2x is equal to y plus 1, and dividing both sides by 2, so y plus 1 divided by 2. This is your step number 2. Now in step number 3 is, we know that y is equal to f of x. From step 1 you know it, and this is the explanation of that. Now multiplying f inverse on both sides. Multiplying f inverse from the left side. So you see that this is the inverse of this function. So you know that when inverse of a function is multiplied with the original function, you always get identity. So identity multiplied by x, you will get x. So f inverse of y is equal to x. So now this x is equal to y plus 1 divided by 2. So replace this x by f inverse of y. So this is the step number 3. So now you need to replace the x by this is your step number 4. Replace x by f inverse of y. So let's say this is equation 1. Equation 1 becomes f inverse of y is equal to y plus 1 divided by 2. Now you need to find out f inverse of x. So in step number 5, replace y by x. So we get f inverse of x is equal to x plus 1 divided by 2. So this is the inverse of a given function. The given function is f of x is equal to 2x minus 1. So its inverse is x plus 1 divided by 2. This is also a function. This is a bijective function as well as this is a bijective function. We also already discussed that inverse is exist if and only if the given function is bijective. So the given function is linear. So remember, linear functions are always bijective. So that's why its inverse is possible, and that inverse function must be a bijective function, because this is bijective, this is linear. So you see that this is also a linear function. You may write it like this: 1 divided by 2x plus 1 divided by 2. This is the value of m and this is the value of b, because in general form you write the linear function mx plus b. So f inverse of x can be denoted by g of x. It's your choice, but f raised to minus 1 is the notation for the inverse of a function. So this is the algebraic way to find out the inverse of a function. Inverse of a function, and the function must be bijective. So if a function is bijective, then you can find out the inverse, and that inverse must be a function, and that inverse function will also be a bijective function. So this is the procedure to find out inverse of a function by using algebraic method when the function is given in algebraic form. Okay, now after that we will switch toward the exercise in next video lecture. Thank you.